Continuing our discussion on graphing exponential functions, we're going to look at numbers 10 through 13, which have the natural base e as the base of each exponent. So in number 10, we're going to graph f of x equals e to the x power. And this is a parent graph. Okay? Any parent graph will have a horizontal asymptote located at y equal to 0. So I'm going to draw in the horizontal asymptote with a dotted line at y equal to 0. Now I have to choose x values to plug in and get a y value in return. So just as I did when I had rational bases, for my irrational base, I'm still going to choose x values like -3, -2, -1, 0, 1, 2, and 3. This time, however, I must use a scientific calculator to plug in these specific values. So any problem that has the base of e, you will have access to a scientific calculator. If it has a base that's like 2 or 1/2, you'll probably only have access to a 4-function calculator, and you'll have to know your rules for exponents. All right, e to the -3rd power. So I'm going to hit second and hit the natural log button, which above that is e to the x powered. I'm going to type in -3. Okay. I'm going to probably round to the nearest hundredths. So I'm at like 0.05 when I plug in -3. Okay. Then I'm going to plug in -2. So I go second e to the -2nd power. And I get approximately 0.14. Okay, plug in -1. Whoops, wrong button. So the -1st power, and I get 0.37. Okay, any number to the 0 power is 1, even when the base is e. So e to the 0 power, you will see, is always 1. Okay, e to the 1st power, I get 2.72. Okay, e to the 2nd power, I get it 7.39. E to the 3rd power, I get 20. Too large to graph, so I'm not going to worry about putting that in my table. Okay, I have some points. Now I'm going to plot them. So I'm at -3. I'm really close to the horizontal asymptote, but it's not 0. Okay, -2 is 0.14. -1, I'm at 0.37. 0, 1. 1, I'm at approximately 2.7. 2, I'm at approximately 7.4. And you see this still takes that general shape of an exponential function that represents growth. Okay, all exponential functions have a domain of -infinity to +infinity. The range depends on the location of the asymptote and the curve. So the range for this function is 0 to infinity, with parentheses around the 0, because we can't have part of the curve that falls on the horizontal asymptote. So it cannot be included. Let's try one more. Problem number 11. We have f of x equals e to the x minus 2 power plus 1. Again, I'm not concerned right now about you describing the transformation, but what we do need to take note of is after the exponent, I have a plus 1. This means my graph is shifted up 1 unit, which also shifts the horizontal asymptote. So this horizontal asymptote is located at y equals 1. Now I need to plug in values. Okay. I can start with -3. Now, if I take -3 minus 2, that is e to the -5th power. E to the -5th power is pretty small. but then I also have to add 1 to that, and I get really, really close to 1, like 1.01. So what I might do is I think I'm going to maybe skip -2. Maybe I'll try -1. So if I plug in -1, -1 minus 2 is -3. So I have e to the -3rd power. I need to add 1 to that, so I get approximately 1.05. Okay. I might try plugging in 2. That's still pretty small, so let me try plugging in 2. If I plug in 2, 2 minus 2 is 0. E to the 0 power is 1, and 1 plus 1 is 2. Okay, we plug in 3. 3 minus 2 is 1, so I have e to the 1st power. I'm going to add 1 to that, and I get 3.72. If I plug in 4, 4 minus 2 is 2, so I have e to the 2nd power, add 1 to that, and I get 8.39, and it looks like I can stop there because the next number is going to be off the charts. So horizontal asymptote at y equals 1. And plot your points. I have -3, -1.01. -1 is 1.05. I have 2, 2. I have 3, 3.72. See, I have 4, 8.39. And I can see my curve still represents exponential growth. Okay. My domain is all real numbers, so -infinity to +infinity, and my range goes from the asymptote 1 to infinity. I'm going to have you try number 12 and number 13, and then I would like for you to check your answer using the key provided in Canvas. Good luck!